Hey everyone, welcome back to another episode of the Weekly Coder. I'm Chris, and we are going to basically pick up from where we left off last week. And that's kind of like what we always do. And I'm going to continue on in that tradition because otherwise it would just be extremely complicated and no one could follow anything. So, before we get started, I want to make a quick announcement. I know I usually do these at the end of the video, but honestly, I don't know if you guys stick around for the end of the video as much. So I'm going to start doing these in the beginning so that you guys actually get to hear them. And that is one, check out the new channel that I have with my brother. It's called Code Scruffs, and basically it's us just trying to figure out how to make games completely unscripted, fun, exciting. You guys should check it out if you want to have a couple laughs at our expense. That's great. Another channel, my wife, she started doing a gaming channel where she does playthroughs on older games, not older games, but like she's playing, doing a playthrough of Spyro right now as well as Skyrim, and those are pretty cool because she does some really awesome commentary and some fancy editing. So you guys can check that out. Her name is Donibus Maximus. Don't forget to check out Code Scruffs, and if you like both of those channels, do me a favor and subscribe. We could use some subscribers on both of those. Also, don't forget to, if you like the videos, give them a thumbs up. Also, my channel, if you like it, subscribe. If you like this video, give me a thumbs up. Why don't you give me a thumbs up now? And then that way, later, at the very end, you won't have to think about whether or not you liked the video. You just liked it anyways. So, whether you didn't like it or not, it's not a thought. You just don't even have to worry about it. You already clicked like, so you don't even have to worry about whether or not you like the video. It's perfect in this situation, so just go ahead and click thumbs up. Or if you think you're going to hate it, so you can also click the thumbs down button, but you know what, either way, it's a thumbs up or thumbs down. It's an interaction, which is cool. So, also, don't forget to subscribe to my channel and click that bell for the notifications, because otherwise, you know, you're going to be a subscriber, but you just won't know if I put new videos up. Although I'm very consistent at times to put new videos up, usually once a week, either Saturdays or Sundays, depending on how I feel. Other than that, I also have a Patreon. If you want to support me there, that would be great. Supporters are cool because you guys get exclusive content, which is source code to all the projects that I work on YouTube. So, if you want to start off in a project at a specific location, like if you don't want to watch all the first 10 videos of Tetris, and you want to say, hey, you know what, I just want to learn how to do the Ghost Tetramino. So then you would just download the episode right before that, and then you could just follow along. So that would be cool. So $5 is like the minimum to pledge, and that gets you access to all of that stuff. You can also do it through the join button on YouTube. You can become a member on my YouTube channel. You get a cool badge. The longer you stay a member, the cooler your badge will look. And your support is always welcome. With that said, let's go ahead and jump right into the tutorial. We are going to add some things for Frogger so that he can kind of float on the water. Because right now, when he jumps in the water, he just goes down this endless void. He kind of just drowns. We don't want that happening to Frogger. Frogger needs somewhere that he can hop so that he can finally get over into this safe zone area here that he needs to actually be in. So, I have, like I always do, prepared some assets for us to use. I created 3 different logs. Basically based these on the original Frogger, and I'm going to drag these in. Now, as you know, the first thing we've got to do is we've got to select all these, and we have to change the pixels per unit. Let's change that to 16. Why does it always unselect it? 16 pixels per unit. And then we're going to do a point no filter. Hit apply on that. Alright, so the thing about this log, alright, so let's just go ahead and drag one out here. And we are going to set its position to be 1 in the Y, and the X doesn't matter right now. Let's grab the transform tool. So the log is behind the blue. We don't want it behind the blue. So we also need to change the order in a layer. Let's set that to 5. Alright, so yeah, that's nice because these are 10, the water is like 0, and the log is now at 5, which is perfect because it needs to travel in between those two objects. So let's say we've got our log, And it just kind of goes along like it does here. Once we get to like right here, we kind of want the log to start back over on this side and start coming out through here. So it kind of looks like it continuously loops from one side to the other versus completely disappearing on this end and then reappearing on this side, right? We want it to like look like it's continuously looping, which is going to be not too difficult to do, but maybe difficult to understand how the math kind of works, but it's not that difficult, I promise you. It's going to be very, very simple. And the way we're going to do this is we're going to have two logs. So, you know, it's kind of like it's magic. So what we'll do is we'll have two logs on the screen at the same Y position, and we'll have one log start right about here, and then the other log start right about here, and they're going to be traveling at the same speed, so that once this log reaches the maximum point on the right side to where we know that this other log is here. So basically we want to know when this log at this point reaches this log's position here. When that happens, we're going to send this log to this side, and then as the log that's over here starts to disappear, this one starts to emerge, and that's going to make it look like the log is just continuously moving from one side of the screen to the other. So the first thing we're going to want to do is we're going to create a script. So let's go to the scripts folder and go create and a C# script. So we're going to do log, and we're going to just open that up in monodevelop. And let's see, we don't need the start. Let's get rid of that. We do need some variables. So we need a public variable that is going to be a float, and that's going to be our move speed. And we're going to set that equal to 5. We also need a boolean because we need to know if we're going to move right or left. And we're going to set that to true. And then we're going to need a reference to the number of units that are in our playing field. So we're going to call this play area, and it's going to be a float. And it's going to let's make it read-only. So it's going to be a read-only float, and it's going to be called play area width. And we know that that is 19. And why do we know that that's 19? Because if we go back and look at Unity, we can count all the squares, and it's going to show us that our play area width is 19. Okay. So now what we need to do is we need to actually get a reference position, like we always do for these kinds of things. So we're going to create a vector 2. I'm going to call it position, and we're going to set it equal to the local position of the transform for this game object, for the log. And then, oops. And then at the very end, we're going to say position equals, transform.localPosition equals position. Okay. And then in between, we're going to do some things. So the first thing we're going to say is, hey, do we know if we're going to move right, or are we going to move left? Okay, so either we're going to move right or we're going to move left. And depending on what we do, which direction we're going to do different things. So if we're going to move right, so we're going to say position.x plus equals move speed times time.delta time, which is the basic calculation that we always use for moving things, right? On the opposite end of that, if we're going to move left, we're going to say position.x minus equals, and we're taking away from the position, move speed times time.delta time. All right. So, but if we have this, what's going to happen is the log is just going to keep going in the right direction or keep going just in the left direction. It's not going to actually go back to where it's supposed to go, right? So what we do is we're going to make another if statement inside of an if statement. Imagine that. It's if statementception. If inception. In ifception? If statementception. So here is where the fun begins. We're going to say if, right, the position.x is greater than or equal to the, all right, here we're gonna add some parentheses. The play area width, right? So 19 divided by 2. All right, so we're at 19 divided by 2. That's going to equal 9.5. We're going to say if that's true, we're going to subtract 1 from this. And the reason that we do that is because the way that the log moves across the screen, when we looked at it, there are these two columns on either side. And those columns are 1 unit wide. We want to know when that log gets to the edge of the one column. So it's going to travel the entire distance of the playing field minus 1, because that one column, we need to know if it gets to the edge of the column, not the end of the column, right? So the next thing we need to do, we need to actually add in the play area width minus 1, because that is the length of the travel. And then we're going to just get the size of the sprite renderer, SPRIT renderer, the x, which is the width, and we're going to divide that by 2. All right. So hopefully your guys are still with me with this calculation here. If nothing else, you could just trust me that that provides you with the right number every single time. And by throwing in the size of the log and we're dividing it by 2, we're ensuring that this script will work whether the log is 2 units, 3 units, or 4 units long. Okay? Because, you know, the edge, we're going from the edge. We're always going from the edge of the log. Once the right side of the log reaches the right edge, then we want to send the other log back to the other side. Okay? And you'll see that once we actually visualize it for you. So what we want to do, if that's the case, what we want to do here is we want to set our x position. So position.x equals, we're going to say minus the play area width. So minus 19, okay, divided by 2, which is minus 9.5, minus get component sprite renderer dot size dot x divided by 2. So basically what we're doing here is we're getting the play area width divided by 2, which is 9.5, and then we're subtracting the size divided by 2 of the log. So if the log's 2, this ends up being 1, and 9.5 minus 1 is 10.5. Or sorry, minus 10.5, negative 10.5. So negative 10.5 will get us on the outer leftmost edge of our playing field. All right. So now we do the same thing, but in reverse, for if the log actually travels left instead of right. So we're going to say if position.x is less than or equal to minus play area width divided by 2 plus 1 minus play area width minus 1 plus get component sprite renderer dot size dot x divided by 2. If that's true, then we say position dot x equals play area width divided by 2 plus get component sprite renderer dot size dot x divided by 2. All right, so we've got our script, and that's basically all we need. This should make everything work. So we're going to save that. Going to go here. All right, so now as far as these logs are concerned, we need to add the collidable object because it's a safe object for the frog. And then we need to add the log script that we just created. Oops. And finally, we need to actually go to the tag, and we need to add the collidable object tag. And I'm going to take this log, and I'm going to put it right over here. And that looks like it's going to be at about 7.5. And then I'm going to go over here to the hierarchy, and I'm going to right click and click duplicate so that I don't have to set up this, all of this again. So we're going to move this to right over here and set it up. That's going to be at negative 10.5. Alright, so the idea is that these two logs are going to travel together at the same speed. And then once this log reaches here, the math that we did in that if statement is going to calculate what this distance should be. And in this case, it's going to be 25.5. It's going to calculate that. And if this hits 25.5 or it's higher than 25.5, it's going to take this log and it's going to send it right over here. So and see, and then the cycle starts back over. And then this log is going to check to see if it's at that width, or at that, not width, but X position. So let's go ahead and put these back to where they were. And let's play the game. And I'm going to put it on the scene view for you guys. So I'm going to pause this. And I'm going to add in the scene view so that you guys can see how these logs are actually traveling versus how it looks in the game view. So once we get here, this log will go to the other side. See how that happened? And if we look in here, it just looks like a seamless transition from one log to the next. So it just looks like this log is just constantly looping. It doesn't look like there's two logs floating at any point in time, right? So with that in mind, we should be able to go back to graphics. We should be able to drag in the medium log. Two of them. Actually, let's just do one. Let's get that one situated. We need to also set the order and layer to be 5. Let's go ahead and tag it as collidable. Let's put it at Y2. And let's go ahead and put it out here. And it looks like it's going to be at negative 11.5. And let's go ahead and add our scripts. So we need the log. And we need the collidable. Let's mark it as is safe, and we're going to make it move left, and we're going to make this one go a little slower. So let's make it go at like 3. And we are going to duplicate it. So now we have 2 logs. We're going to set this one out right here. Okay, that's how we get our distance. And 6.5. Okay, so if you don't want to start these in that location, you can literally select both of them. So you just do this. And then if you say, let's say you want to start them off like right here, that's fine. So we just click play. And then watch, as this one approaches here, this one's going to go over here. There. And now it just looks like one log basically looping around. Right? How cool is that? Let's go ahead and throw in that last log, the large one. And we're gonna go and put that one at, let's put it at 3. Let's set its order and layer to 5. Let's tag it as collidable. Let's add the collidable object script, mark it as safe. And let's add the log script and make it go right. And we're going to make it go a little faster, so I'll put it at 8. And then I'm going to do the same thing just to get the actual distance between these, because the distance should always be the same, and that's one thing that you have to make certain of. So this is negative 13.5. We'll duplicate it, and we'll put it right here. 4.5. So it's always from the rightmost edge to the rightmost edge. And that'll be your distance between these two. Once you have that figured out, you can take both of these logs and you can literally start them wherever you like. And then when we press play, you can see it just looks like it wraps around like it should. Yeah, looks good. I have to close this scene view because it's messing with me. Yeah, it looks really good. Okay, so I'm not going to get too much into, I mean, I guess I'll show you that these logs don't actually work right now. Even though they are tagged as collidable and they are marked as safe, we don't have any way of telling the frog that he's on a log and that he needs to move with the log as the log moves. So, yeah. We can't sit on the log yet. Not to mention that when we collide with the log, we're also colliding with the water at the same time. And we haven't put any logic into our game that says, hey, what's going to happen if we're both on the water and the log at the same time? We have to say, oh, well, since we're on the log, it doesn't matter if we're on the water. As long as we're on the log, we're going to be safe. But we have to test for both. And let's see what else. We also have to make it so that once the frog is actually on the log, it updates its X position based on the X position of the log. And not the actual X position of the log, but the actual move speed. So the frog is going to start moving with the log, and then we also have to take into account that the frog can still be manipulated via the arrow keys. So that's where the logs are going to get more difficult. But what we'll probably do in the next episode is we'll add the lily pads. So then once we have both the logs and the lily pads actually functional as they were in the actual game, then we're going to go ahead and make them actually functional and add some code to make it so that the frog can be on the logs or the lily pads. And then after that, we'll probably go into like keeping track of lives, keeping track of timer, and then once we get all done with that, we'll probably work on getting into those win spots, and then maybe even going as far as adding like another level after that. So for now, that is all. The only thing I'm going to add at the end, since I already added a lot of it at the beginning, is if you like the channel, subscribe. I always could use more subscribers. If you liked the video, give me a thumbs up. If you didn't, give me a thumbs down. If you want to get notified when there's new videos, don't forget to click on the bell after you click subscribe. Or if you're already subscribed, you can still click on the bell. It's still there. It's still there for you, waiting for you to click. It says click me for notifications. So that way you guys can see all of my videos as I post them, because that's important, right? So anyways, that'll be the end of that video, and I'll see you guys next week.